This is a poster presentation for Duke 7K Switchgear Digital Relay Upgrade Phase 2. My name is Donald Intel, my teammate is Andrew Dalgety, and our project lead is David Newton. The team mentor is Dr. Cox and Dr. Usaba from UNCC. Our industry supporter is Brian Casey from Duke Energy. This project was split into two phases, with Phase 1 being completed in spring 2020. Phase 2 of the project tasked the team with researching relay philosophy and relay technique in order to create a business case for the aging analog relay commonly seen at McGuire plant. This case then will be presented to McGuire Health Committee for a clear direction for an upgrade path.
This is a general layout for our Duke 7KV project. First and foremost, the team reviewed all documents from the Phase 1 team and files provided by our supporter, Mr. Casey. From this, the team gathered a strong understanding of how to implement different types of relay schemes, such as digital, redundant, and hybrid. Business cases were constructed for the 1TA breaker, which can be utilized for 1TB, 1TC, and 1TD due to their negligible differences. The team will then create setting files and logic for the motors and load centers for the chosen design path. Implementation of the hot bus transfer followed by ComTrod file construction and testing will conclude the project. If time remains, design drawing changes will be implemented for the upgrade path selected. This shows an overview of each of the project milestones. These were discussed in more detail on the previous slide. This gives a visual overview of the tasks needed to be complete. This shows our reasoning process. The documents provided by Mr. Casey aided in the understanding of relay philosophy and the certain analog relays commonly seen at the McGuire plant which needed to be replaced. SEL was chosen instead of ABB or ITE due to their product availability, pricing, build quality, and organization of their support documents for each relay. The main thing to take away from this section is in regards to figures 6 and 7, which are the functional diagrams provided by the datasheets. These were utilized to confirm that the numerical relay under investigation could perform the same functions of the analog one being replaced. Due to viewing purposes, the hybrid business case is the only case presented here, as the rest of them are located on the actual poster itself. All relays were priced based off of SEL retail prices with 2 Duke technicians undergoing 12 hours of labor at approximately $100 per hour. Per the McGuire Health Committee, the hybrid case was chosen for implementation. As you can see in figure 8, the total for the hybrid case was approximately 180 grand.
In conclusion of semester 1, the team reviewed all files from Phase 1 and from the supporter. Relay philosophy and ANSI device number helped aid the team in creating a business case required. The team also concerned about retrofitting relay option for an existing analog relays. The team compiled a list of compatible relays for each analog relay being replaced. Following this, the team created a business case for each relay scheme under investigation. This scheme was then presented to McGuire Plant Health Committee. Ultimately, the committee decided to go with the hybrid option. Now the team is currently working toward creating a setting file and logic for the new relays using SEL accelerator software.
Any remaining work regarding accelerator software will be continued at the beginning of the second semester. After this, implementation of the fast bus transfer, ComTrod file generation, and ComTrod testing will conclude semester 2. As stated before, design drawing changes will be implemented if time permits.
And this is all references.